Yes, two sets of different sized service conductors can be installed in the same pipe as long as they are not paralleled. Article 230.7 permits multiple services to be installed in the same raceway. When more than 3 current carrying conductors are installed in the same raceway, the adjustment factors in Table 310.15b2 do not apply. The ampacity of the conductors must be adjusted using the applicable Table 310.15b6 or 310.15b7, which take into account the number of conductors, the type of insulation, and the ambient temperature. Using Table 310.15b6 to size conductors, there is no need to apply any diversity adjustments. To elaborate further, let's break down the considerations for installing multiple service conductors in a single conduit, focusing on compliance with the National Electrical Code. Firstly, the permissibility of installing two sets of different sized service conductors in the same conduit is governed by NEC Section 230.7. This section essentially allows multiple services, which in your scenario are the 200 amp service and the 100 amp service, to be installed within the same raceway, such as the 2.5-inch polyvinyl chloride conduit you plan to use. A key condition here is that the conductors are not paralleled. Paralleling conductors involves connecting multiple conductors together at both ends to increase the current carrying capacity for a single circuit. In your case, each set of conductors, one set sized for 200 amps and the other for 100 amps, feed separate service panels, thus they are not considered to be in parallel. Now let's move on to the second critical point, the interpretation of diversity and the application of derating factors when you have more than 3 current carrying conductors in the same conduit. This is where understanding the correct table in the NEC is vital. The crucial point is that the adjustment factors found in Table 310.15b2 do not apply when you are using Table 310.15b6 or 310.15b7 to determine the ampacity of your conductors. Table 310.15b2 provides adjustment factors for the ampacity of conductors based on the number of current carrying conductors in a raceway or cable. These factors are typically used in conjunction with the ampacity tables 310.16 through 310.19. However, when dealing with service conductors in a single-family dwelling, Table 310.15b6 offers an alternative method for determining the allowable ampacity of the service entrance conductors. This table already incorporates certain assumptions about the load diversity typically found in a dwelling unit. Therefore, it negates the need for additional derating based on the number of conductors. To summarize, because you are using Table 310.15b6 to size the service entrance conductors for both the 200 amp and 100 amp panels, you do not have to apply any further derating adjustments based on the number of current carrying conductors in the conduit. This simplifies the installation and ensures you are not unnecessarily oversizing the conductors. The practical implication of this is significant. It means that you can select the conductor size directly from Table 310.15b6 based on the service size, without having to reduce the ampacity due to the presence of multiple conductors in the same conduit. This approach streamlines the conductor selection process and potentially reduces the cost of materials by allowing for smaller conductor sizes compared to a scenario where derating factors would apply. It is important to ensure that the installation adheres to all other relevant NEC requirements such as proper overcurrent protection, grounding, and bonding. Additionally, the physical installation of the conduit and conductors must comply with the NEC requirements for support, protection, and separation from other systems. Always consult the latest edition of the NEC and seek guidance from a qualified electrical inspector or engineer if you have any doubts or encounter unique circumstances during the installation. A brief review of other relevant sections of the National Electrical Code that are applicable to this installation is prudent. Let's look at Article 310, Conductors for General Wiring. This article provides the general requirements for conductors used in electrical installations. It covers topics such as conductor identification, insulation types, ampacity, and installation methods. Section 310.15 specifically addresses ampacity, outlining how to determine the allowable current carrying capacity of conductors based on factors such as insulation type, ambient temperature, and the number of conductors in a raceway or cable. Article 230, Services, covers the requirements for service entrances, which are the conductors and equipment that bring power from the utility company to the building. This article includes sections on service conductor sizing, overcurrent protection, grounding, and disconnecting means. As previously mentioned, Section 230.7 specifically addresses the installation of multiple services in a single building. Article 250, Grounding and Bonding, establishes the requirements for grounding and bonding electrical systems to ensure safety and minimize the risk of electrical shock. This article covers topics such as grounding electrode systems, equipment grounding conductors, and bonding of metal enclosures. Article 300, Wiring Methods, outlines the general requirements for wiring methods, including conduit, cable, and other types of raceways. This article covers topics such as support, protection, and installation of wiring methods. Section 300.3 specifically addresses the installation of conductors of different systems in the same raceway, which is relevant to the situation where multiple service conductors are installed in the same conduit. Article 314, Outlet, Device, Pull and Junction Boxes, Conduit Bodies, Fittings, and Manholes, provides requirements for the installation of boxes, conduit bodies, and fittings used to enclose and protect electrical conductors. This article covers topics such as box fill calculations, support, and accessibility. Article 352, Rigid polyvinyl chloride conduit, covers the requirements for rigid polyvinyl chloride conduit, including installation methods, support, and expansion fittings. This article is relevant to the installation because the service conductors are run in polyvinyl chloride conduit. Article 408, Switchboards, Switchgear, and Panel Boards, provides requirements for the installation of switchboards, switchgear, and panel boards, which are used to distribute electrical power throughout a building. This article covers topics such as overcurrent protection, grounding, and working clearances. In the specific case of the 200 amp and 100 amp service panels, Article 408 would apply to their installation and wiring. Now let's discuss the appropriate conductor sizing. Table 310.15b6 allows a reduced ampacity for service conductors based on the size of the service. This table typically applies to single-family dwellings and considers the diversity of loads in a residential setting. For example, a 200 amp service may not require conductors rated for a full 200 amps, and a 100 amp service may not require conductors rated for 100 amps. Using this table, the minimum conductor size can be determined, provided that the entire load calculation for the dwelling does not exceed the ampacity allowed by the table. Considering the ground, ensure the grounding electrode system is properly installed and connected to both service panels. This typically involves connecting to a grounding electrode, such as a ground rod, water pipe, or concrete encased electrode, and running a grounding electrode conductor to the service panels. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. Also, bond all metal enclosures and equipment to the grounding system to create a low impedance path for fault current. This typically involves running equipment grounding conductors from the service panels to all metal enclosures, such as junction boxes, conduit, and equipment. The size of the equipment grounding conductors is determined by NEC Table 250.122 based on the size of the overcurrent protection device. With overcurrent protection, each service conductor must be protected by an overcurrent protection device, such as a circuit breaker or fuse, size according to the ampacity of the conductor. The overcurrent protection device must be located at the point where the service conductors enter the building, or as close as practicable. The 200 amp service panel must have a 200 amp main breaker, and the 100 amp service panel must have a 100 amp main breaker. Using polyvinyl chloride conduit, ensure the polyvinyl chloride conduit is properly installed and supported according to NEC Article 352. This includes using appropriate fittings, supports, and expansion joints. The polyvinyl chloride conduit must be installed in a neat and workmanlike manner and protected from physical damage. Section 300.11 requires that raceways, cable assemblies, and cable trays be securely fastened in place. It also addresses the support requirements for different wiring methods. When installing multiple service conductors in a single conduit, you must ensure that the conduit is properly sized to accommodate all of the conductors. The NEC specifies the maximum allowable fill for conduits, which is typically 40% of the cross-sectional area. You can refer to NEC Chapter 9, Table 1 for conduit fill requirements. In addition to the general requirements for conductor ampacity, the NEC also provides specific rules for derating conductors in certain situations. For example, if conductors are installed in an area with a high ambient temperature, their ampacity must be derated to account for the increased heat. This is addressed in NEC Section 310.15. With voltage drop is the reduction in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, you should use conductors that are large enough to carry the load without excessive voltage drop. With working space and access, NEC Section 110.26 requires that sufficient working space be provided around electrical equipment to allow for safe and convenient operation and maintenance. This working space must be clear of obstructions and must provide adequate headroom and illumination. In addition, NEC Section 110.32 requires that electrical equipment be readily accessible for maintenance and repair. It is important to note that the NEC is a complex and constantly evolving document, and it is important to stay up to date with the latest requirement. It is also important to consult with a qualified electrical inspector or engineer to ensure that your electrical installation complies with all applicable codes and regulations. Proper planning, conductor selection, and installation techniques are essential for ensuring a safe and reliable electrical system. Understanding and adhering to the NEC guidelines is crucial for electrical installations.